Hello and welcome to TidyX episode 82. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick, and you can find the screencast on Twitter at Tidy_explained, or on Gmail, tidy.explained@gmail.com if you'd like to get in contact with us. Of course, you can always go on the GitHub repo and open up an issue. We'd love it if you'd go on the YouTube channel, like and subscribe, drop a comment or a question. We've had some great comments over the past few weeks. And
Really
as of last week, we've also put up on the YouTube channel in the comments section our Patreon. So, no pressure. If you like what we're doing and you want to buy us a coffee or a beer, we do both live in Seattle, and beverages are those two beverages are very popular up here.
Quite good.
We'd greatly appreciate it.
Hey, or beer sponsors.
Yeah,
We'll take a beer sponsor too.
yeah, we'll totally take a beer sponsor.
But yeah, so this last several weeks here, we've been learning about Tidymodels. We've been taking you with us on the journey as we figure out how to apply Tidymodels to various different toolings, just as an educational experience for all of us.
Yeah.
And so for the last several weeks, we've done a lot of regression tuning, but these last 2 weeks, we started doing classification. What are we doing this week, Patrick, as I share the screen?
Yep. So last week we did logistic regression, basically the most simple form of classification where you have two classes. We did win-loss in NHL games. This week, we're going to get into multi-class classification. So when you have more than two classes and you want to look at what's the probability of the features of our model predicting or forecasting whether or not someone or something is going to fall in one of n number of classes. And so for that, we're going to use a random forest classification. We've kind of skipped over decision trees and jumped straight to random forests. For the reason only that we did a regression decision tree a couple episodes ago, I think episode 80. So if you want to see how to fit, regression trees, it's literally the same for classification. You're just changing the mode from regression to classification. So we're going to jump over that, and we're going to go with a random forest classification, which is a type of model strategy that's basically it's a group learner, right? Mm-hmm. It's like it's like a wisdom of the crowd learner. It's going to build tons of decision trees and try and make predictions on that. Yep. If you'd like to really get into the nuts and bolts, we did a machine learning classification series on pitch FX data some number of episodes ago.
Yeah.
And we really get into the nuts and bolts of what these things are and how they work, but we didn't do it in Tidymodels. So today we're going to learn this in Tidymodels.
Let's do this thing. All right, so we're going to get started with this. We're using knitr, we're using our markdown. So we're going to set our knitr options to echo as true. So when we knit this report, it's going to show all the code that we've got. We're going to use the library tidyverse for all our data manipulation needs. We're going to use Tidymodels because that's what we're learning about right now. And it's got a bunch of modeling tools, and as you can see, a whole mess of different packages under the Tidymodels framework. And then this week, the data set that we're going to use is from the Palmer Penguins data set. So we're going to call it library Palmer Penguins. When you do that, it loads the Penguins data set into your environment, into your namespace. So we can take a quick peek at that. And so we've got 8 different columns here: species, island, bill length in millimeters, bill depth in millimeters, flipper length in millimeters, body mass in grams, the sex of the penguin, and the year that they got this data in. And so as you can see here, we already see a couple NAs. For example, for this Adeli, for some reason, they recorded that they took it, but nothing about it. So we have a feeling, though, that there could be some missing data, so we're going to run that. And it looks like there are two observations that are missing bill length, bill depth, flipper length, mass, which, happens. And then 11 that are missing sex. So maybe they couldn't identify sex, or they just didn't record it. Who knows? And so here are the 11 records that are missing sex. So 2 of these guys probably will just be thrown away. But the rest of these we could still use if we could still use sex if we impute that. So we're going to remove those. We're going to remove all the cases where bill depth millimeters and NA. So these 2 guys here, because we can't really use anything from it.
No information. Yeah.
You're not useful. Get out. We're going to do our, as you can see here, if you have seen the last several episodes, we're trying to create like a markdown process that we can follow and apply every time we want to use the Tidymodels framework. So this is like our data cleaning and initial data processing. Now we're going to do a testing and training split. So that's a random process. So we're going to set our seed so that you can always reproduce what we did. We're going to use the function initial split on this cleaned data set. And then we're going to stratify by species, which means that in our split, it's going to ensure that we have all 3 species classes existing in our training and testing data sets. And we'll create penguin split. We're going to pull out the train data set using the training function and the test data set using the test function so that we can use that going forward, because we're going to do some fun cross-validation. Once again, this is a random process, so we will set our seed. We will use the vfold CV function to do the cross-fold validation. The data set we're going to be using is the training data set here, and we're going to set the number of folds to be 5. So we're going to do 5-fold cross-validation. And there we go. We've got our splits there of 5-fold. So this is, there are 256 records in our training data set, and now we've got it split even more, so we have 5 different folds, and so it's random assortments of 5. Or 1/5 in the train cross, or the cross training, and then 1/5 in the test training. And now we're going to go into our model specification. And Patrick, do you want to take it from there?
Yep. So as Alice said, we're trying to work through our own sort of framework of doing these things. So after we split the data, we feel like the next best thing to do would be to initialize the model specification that you're interested in. In this case, we're doing random forest. So we're going to set up this element called rf_fit, and we're going to call the random forest function. And we could leave this blank, in which case we would get returned all of the defaults. But we're going to say that we want to specify mtry. So mtry is basically the number of predictors used within the random forest when it's trying to make, so randomly drawing a different number of predictors to try and make a split within these several hundreds of trees within the forest. It defaults when you're doing classification to square root of n number of predictors. We have 5, so it would default to something a little over 2, to 2.2, 2.3, something like that. So we're going to say that we want to go ahead and we want to tune this. So we're going to random forest. We're going to mtry. Instead of passing it a number, we're going to say we're going to tune it. Then we're going to pipe in the engine. So in this case, we want to use the random forest package, which is a pretty popular package for setting random forests within R. And we set importance to equal to true because we're going to want to know which variables are most important. We're actually going to use that in plotting later on once we fit the model. And then, as I said, last week we did, or 2 weeks ago, we did setting the mode to regression. This week, we're going to set the mode to classification. And that's important for this kind of model, unlike logistic regression, which can only be classification. In this kind of model, random forest can be regression as well. So we want to explicitly say, hey, we're going to do a classification model. Now, there's a few ways to tune the mtry grid, and we're going to show you 2 of them. This is way 1, which we did 2 episodes ago when we were fitting regression on decision trees. This is where you explicitly say, I have a grid of values that I want to try and tune over. And if we had more elements that we were tuning within this random forest, we would put it in this grid as well, and we'd create this sort of coordinate system of all of the different permutations that you could do. Exactly. So in this case, we're only tuning 1 variable. So we're just going to set the range to be 1 to 5, since we have only 5 predictors, and so there's going to be only 5 levels. So we'll go ahead and set that, and it's just going to give us this grid of 1, 2, 3, 4, 5. Easy enough. Okay, so now we've gone through, we've initialized the model. The next thing is to set up the recipe. So remember, the recipe is where we're doing any of our pre-processing. So we're going to create a penguins recipe. We're going to pass it our model that we're interested in. In this case, we're trying to predict the species. So 1 of 3 species from all of the variables within the model, or within the data, all 5. The data that we're going to do this on is the train data. We know that we had some NAs in the variable sex, and so we're going to actually impute those using k nearest neighbor and 3 neighbors. So it's basically going to look at the data, and it's going to say, hey, go ahead and forecast out whether it's a male or female penguin in those, what were we left with? I think 9 instances, because we removed 2 of them with no data. Go ahead and forecast out whether they were male or female using the 3 closest neighbors of the other observed data. So we're going to use KNN to impute that. And then the other thing we're going to do here, which is really interesting and useful, is we're going to update the role of 2 of the variables. So we have 5 predictors in our model, but we actually have 7 variables within the data set. We don't want to use year for the model prediction because we don't think it's going to be useful, and island. So we're going to remove them. Instead of just removing those, instead of dropping those columns altogether, we're going to update their role to be ID. And so what this is basically saying is it's saying, hey, when you go and build the model, don't worry about using those 2 columns of data, but keep them in the data set, because maybe once we go through building this model, we might want to use those for plotting purposes to see like where the model's breaking down, other types of variables that might be interesting. So we're going to set those to ID. So if we run this penguins recipe, we can double check ourselves by saying summary penguins recipe. So we can wrap it in a summary function, and it's going to tell us which variables we've now specified as being the predictors, the outcome variable, and then the ID, meaning they're not going to be fit into the model. Okay, great. So now we've checked where we're at. Everything looks totally good, and we feel like we're in a good spot. So we're going to move on. So remember, we had a few NAs in the train and test set just to make sure that our recipe is working. We can go ahead and just prep that recipe and bake it and just see this is what the model's going to see. Great. We've fixed rows 6 and 7, and it looks like one was male and the other was female. Okay, perfect.
Well, according to k nearest neighbors.
According to k nearest neighbor, right. So now let's move into our workflow. So we've set the recipe, we've pre-processed the data, let's put it into a workflow, and we're going to add that recipe in. We're going to say, hey, do all that pre-processing stuff that we told you to do it on the data, and then add that model in, the RF fit model, so we can make our forecasts. And so now we have a recipe that or a workflow that we can check out. We say we wanted a random forest. We pre-processed a few variables. We've got our arguments, our main arguments that we're going to tune, which is going to be the mtry, and we're pretty much ready to rock and roll.
Boom.
All right.
Let's go
ahead
going.
And let's you take them through fitting it.
All right. So now we're going to go through and fit it, and because this is a random forest, there's a bunch of different things it's going to be running, and because we're tuning, there's even more. So we're going to set things to be running in parallel. So we're going to use the do parallel package and register do parallel. So it's going to be using about half the number of cores that I have on my computer. Once again, random process. I seem to have gotten all the random processes this week. So we're going to set a seed to make sure that it's consistent. And now we're going to tune it. And what we're going to use is the tune grid function. And what this is going to do is, based on the grid that we feed into it, it's going to train on the workflow that we pass to it using those cross-fold validation. I can speak. Cross-fold validation splits that we have here, and tune it based off the grid that we feed it. And so there's, as Patrick alluded to, there's 2 different ways that you can do this. The one that we showed you 2 weeks ago, which is passing in that tune grid that we have. Here it's rather boring because we're only tuning across one parameter, mtry, and there's not many predictors, and so there's 1 through 5. But what you could also do is, if you don't really know and you don't really care what set of parameters you want to tune across, what you can do is you can set the grid to be an integer. And it will randomly select the number, the integer that you put into it, a combination of your different parameters that you might want to try. And so once again, this is rather straightforward because we don't have many things that we're training across. We're only training across mtry, but these are the two ways to do it. And the nifty thing about this setting the grid to be an integer is it kind of automatically knows the limits of the data you're feeding into it. And so we only have 5 predictors. The maximum mtry could be is 5. And so it's not going to try to set mtry to be 7 or 10 or something random like that, because it already knows that it can't do that. And so it's kind of pre-selecting for you. Mm-hmm. So we're going to make sure to set the seed, run this. And so as you can see here, creating pre-processing data to finalize unknown parameter mtry. So it kind of sorted that out for us. So once again, Tidymodels team coming in clutch and and helping us out and saving us from ourselves. So now we've got this now fit workflow that's been trained across 5 different folds here. We can collect the metrics. So this is now how did our model perform based on all the different tuning parameters. So in this case, mtry. Mm-hmm. So it's going to tell us if we had an mtry of 4, the accuracy of our multi-class predictor was 0.973, and the mtry of 4, our ROC AUC, was 0.997. And if you look at the different ones, it looks like the mtry of 2, interestingly, best performance for accuracy in ROC AUC, which is, and to me, that's rather interesting, that because normally you'd expect whenever you have more parameters for it to be more accurate, but apparently not. We're going to use the autoplot function to plot the different tuning parameters, so the different mtries we tried against the different metrics, so accuracy and ROC. So you can see here, bloop, bloop. So they just got worse. The more randomly selected predictors we tried here. And now we're going to select, okay, now which one is the best? Which one should we be using based on ROC AUC? So it's going to pick what is the maximum value here. So mtry is 2. There you go. So Patrick and I played around with this for a little bit because we were a little bit like, how? There's got to be a way to tell Tidymodels, I want to keep the workflow, but select the best mtry. We're no longer tuning. We've already trained it across the tuning. What is the best one we should be using? Well, of course, they've thought about that, naturally. And so that is the finalize workflow function. In the past, we've done the finalize model. Same idea. You pass in now the workflow that we were tuning across and say, okay, now select the best one based on ROC. And this is the tuned result here. So we've run that, and now we get a workflow that no longer has to be trained. It knows that the best mtry, well, it still has to be trained, I guess. We're no longer figuring out what arguments we need to be using. It now knows. So we've got that all set up. Patrick, do you want to take us through this last piece?
Yep. So now that we've got the workflow finalized, we're going to fit the final model to our training data and then make some predictions on the test data and collect those predictions. So we're going to get a final fit here, and we're going to take that finalized workflow and we're going to pipe in last fit. And the split that we're going to do this on is the penguin split. So now we're basically going to use all of the data that we originally started with so that the model can get optimized. We've selected the most optimal model on that training set, and now we've applied it to the test set. And so now we have the final fit in this element here called Penguins Fit Final. All right, and so there we see what we got there. We're going to make our, as we said, we set the importance to true so that we could do this little bit. We load the VIP package for variables of importance, and we're going to actually take that final fit. We're going to extract the fit parsnip. So we're going to actually pull out the fit. So if you just ran that piece here, this is basically what you would see if you were to build this random forest model in the random forest package. and then called the model, this is what you would see. You'd see the information about the model call, what the mtry was, like the number of trees that were fit, the out of sample error rate, the confusion matrix. You get all this information kicked out. So there we see our confusion matrix. We see how well the model did on different types of species. So we're going to extract that out. And then in this VIP function, we want to say that we're going to do a column model. You could do points if you wanted. So if you wanted just little dots, that's fine. We decided to do column. We're going to set the aesthetics to be black around the edges and then fill it pale green with a little bit of opacity to it. So make it a little see-through, opaque. And then theme classic is going to basically get rid of the grid lines. And so now we see that bill length in millimeters had the largest importance when it came to building this random forest and figuring out where to make splits in the data in order to predict the species class. Bill length was of the most important, and then bill depth. So it looks like information about the bill is most important in determining the species, and then it gets into flipper length, and then body mass, and then finally the sex doesn't seem to matter, which it probably shouldn't, right? Because the species is the species.
Sex should have no impact on prediction of the actual species, unless there's an imbalance in the.
Unless there's an imbalance, or it's a species of only one sex, I guess.
Which they won't last very long.
It doesn't. Biologically, I'm not sure that would work out. So
last I heard.
So we fit the model. We've got it fit on the training data. We've plopped it onto the test set data to make the prediction. So here, which I think those comments are like old, but
let's remove those.
Probably don't need them. Fit test. So we're going to take that final fit and we're going to collect the prediction. So the collect predictions function gives us this super handy Tibble output. I think we're too long. There we go. So we're super handy Tibble output that shows us the probabilities. So the pred Adelie, pred chinstrap, pred gin2. So for example, line 1, we have the prediction that it's an Adelie at nearly 99, well, nearly 100%, right? It's pretty certain that it's an Adelie. There's only a 0.004, so a 0.4% probability of it being a chinstrap. The model says there's no way this is a gin2. It was row number 5 in the data. And so because of the highest class being probability being Adelie, it's going to predict class Adelie. Okay, great. This is useful because now we can then go ahead and set up our confusion matrix that we saw in the extract fit parsnip. This is now on the test set. So we're actually going to extract, use the information fit test species is the actual, so that's the ground truth, and then fit test.pred is the predicted class. And there we see the model did pretty darn well. It had a little bit of trouble there where it thought 2 of the Adelies were chinstraps, and it thought one of the Adelies, it thought 2 chins. It believed there was a. Oh, sorry, the actual is on the
left
vertical. That's why I'm reading it backwards. Yeah, so it predicted Adelie twice when it was actually a chinstrap, and it predicted chinstrap once when it was actually an Adelie, and it got all of the Gen2s 100% correct. And so we can, really good. And we can actually make a visual of this. So why don't you talk them through plotting our ROC curve?
Mm-hmm. So just like we did with our prior cross-fold validation split, what we're going to do is we're going to run collect metrics to look at the overall accuracy, and this is comparing the model that is trained on the full train data set, because now we know what mtry to be using, and how did it perform against the test data set. So we're going to run that, and what do you know? So on data it's never seen before, it was 96.5% accurate, which is pretty solid. I mean, that jives with the 3 missing there. And then the ROC AUC, so the area under the curve of the receiver operating characteristics, was 0.995. So pretty darn good. Lots of area under that curve. So let's look what did that curve actually look like out of curiosity. So we're going to take the fit test there. So this is our actual fit actual fit output. We're going to run it through the ROC curve function from, I believe this is from the tune package.
Or a yardstick.
Yardstick.
Yeah.
We're going to say, okay, now the ground truth, what we know the output to be, is based on the species column, which is this one here. But what it expects is that to calculate the ROC curve is what is the predicted classes and the probability of those different predicted classes. We talked a little bit about this last week. Now we have multiple classes, and so we have to pass all 3 classes to it for it to know to include all of those. So the prediction, so we include the .pred Adeli, the .pred chinstrap, and the .pred gen2 in those arguments there. And then we're gonna, so we could just run that, and that's kind of an ugly table because it's kind of difficult to understand. So basically, it's looking at the thresholds of confidence and how that impacts the predictability of the plot there. But we can just throw it into an autoplot because we all love plots. We all love pretty things to look at here. And if you look at that, what do you know? There's not much the variability here. It's 100% confident that's going to be Gen 2. There's no worries about that. And then there is a little bit of change in the Adeli and chinstrap as you change the threshold in order to call that prediction. So and that's to be expected. If you look at the actual data and try to plot all of it over, there's a little bit of overlap in the Adeli and chinstrap and none with the Gen 2. So this totally makes sense here, and it's a really high probability. And this is how you go through and train a model, if you don't, a random forest model, using Tidymodels without knowing the number of mtry you should be using. Get that into your output workflow, and then see how it performs on your full data set, or your trained data set from your test data set.
Test data set.
Yes. All the confusing things. But thank you all so much for joining us on this episode of learning about Tidymodels and Tidy Explained. As always, my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And my name's Patrick Ward. You can find me on Twitter at OSPPatrick. And the screencast is on Twitter at Tidy_Explained, or on Gmail if you want to send us an email, tidy.explained@gmail.com. You can always open up an issue on the GitHub repo, or like and subscribe on the YouTube channel. Drop us a comment there, or go into the comments section, info section on that YouTube channel. And if you like what we're doing, you'll see our Patreon page. If you feel like you'd like to contribute and buy us a beer or coffee, we would appreciate it.
Yeah. Thank you all so much. Keep on exploring your world.